Okay, so last week we had a pretty thorough recording about sine, arcsine, and the nature of the function, right? Which one is one-to-one and which one is not. And these questions, are partially reflected on your quizzes. And I hope you guys understand completely what we cover, because on the quiz, we can only cover, certain aspects of them. Okay, how to evaluate. So ARD, from the ARD's perspective, right? If we go back to see from ARD's perspective, right? From ARD's perspective, what do you see on ARD? Have you thought of that? I emphasize ARD from the beginning, right? I emphasize ARD from the beginning. You know what to do with the curve, right? And we also know what to do with the unit circle, So if we look at the curve, right? If we look at the sine curve and the unit circle, okay, we have a picture here, right? I'm gonna take this one over here. Okay. So let's recap. Wait. So 0, 4. Recap. Okay, maybe you have some questions from here. From ARD's perspective, at the beginning of the semester, I've been talking about ARD is the ultimate centerpiece of trigonometry. Okay, how so? Okay. If you look at the curve, if you look at the sine curve, right now you know how to read the sine curve, right? We know how to read the sine curve. You have an arbitrary point on the curve, right? And this point will tell you the angle. Okay. It will also tell you sine of this angle. Okay, that's what the curve tells us. Very good. So from A to D, do you see that? From A to D. That's from A to D. Okay, A to D directly. You see that? A to D. A to D. So this sine curve tells us from A to D. So if you want to know, right? You're given an angle from the sine curve, you'll be able to read that angle, read that ratio directly from that curve. Yes? Now, from the unit circle's perspective, okay, you're given an angle, right? And you measure this angle according to definition, either positive or negative. If the positive angle is counterclockwise, if the negative angle is clockwise, and you measure the angle, right? So we will use definition. Okay, we'll use definition, and we also get to ARD. Sine of okay, sine of A. So we use definition. We use the definition. Definition will also get us to the output we wanted. Okay, so that's ARD. Okay, so from A to RD. What's the role of R in the definition? Well, R is a reference angle. It's very important, right? So ARD again. Okay, ARD again. But this curve gets you to a D much more faster, much more faster if you know how to read this curve. Now, let's look at the arc sine. Okay, let's look at the arc sine. What about the arc sine? What is arc sine? Right, in terms of ARD.
DRA.
That's right. That's right. Excellent. Okay. Very good answer. Very good answer. Okay. Suppose this curve is not a sine curve, it's arc sine. Okay, so I'm gonna move this, become arc sine. Okay, so we have this curve. We have this curve, right? So I need to make, I'm gonna make some adjustment. Okay, hold on, from 1 to +1, and the range is from -π/2 to π/2, right? Now, this will be -2, +2 for that matter. Okay, so that's the arc sine. We know arc sine, we've done we have done some points on the arc sine, so I'm not going to repeat that, okay? We just focus on this perspective of ARD. Okay, so that the gentleman who said that, could you type what you said on chat? Whoever said DRA. Okay. Thank you. Thank you, Kevin. Good job. Okay. So DRA, why DRA, right? Because arc sine take the input of ratio, and this ratio given to arc sine. Given to arc sine of the ratio. Okay, you see, we emphasize here, I emphasize the nature of the input. In other words, whatever number you enter, it will be treated as a ratio by arc sine for its input. The output is going to be an angle, right? We talk about very carefully about what kind of angle this be. This cannot be any angle, right? It's an angle, but it's not any angle. And the ratio cannot be any ratio, right? And we talk about that. The ratio, okay, that ratio is, what can this ratio be? It's between -1 and +1. Do you guys follow me? And the angle cannot be any angle. Okay, ARD, D is the definition for sine. So when we're dealing with arc sine, the ratio is given. That's why it's DRA. DRA, very good summary. Okay, DRA. And of course, the resulting angle, where can the resulting angle be? It can only be between what? Between what, you guys? Come on, tell me.
Negative pi/2 and pi/2.
That's right. That's right. -π/2 to π/2. Can you guys see the type, the fonts on the screen clearly?
Yes.
You guys see the fonts on the screen clearly?
Yeah.
Okay, let me know, because when I was going to another meeting, sometimes the screen doesn't show as clearly. Okay. But anyway, so that's the arc sine. That's the arc sine. So DRA. Okay. So from D to R to A. Okay. From this curve. Okay. From the arc sine curve, if you give me an arbitrary point, What does this point tell you? The first tell you it is what? It is a ratio, right? And the second one is what? Is the arc sine of that ratio, which is giving you an angle,
Yep.
right? Which give us an angle. So it's from ratio to angle. And of course, we understand that ratio cannot be any ratio. It's between -1 and +1. The angle is going to be between -π/2 to π/2. Is that very clear, everybody? I hope that's very, very clear to you. Okay.
Yes.
It should not confuse anybody. Now, unit circle. What's the perspective on unit circle when we work with arc sine?
The right side, the unit circle.
Right. You can see when you work with arc sine on the unit circle, okay, you are not going to need quadrant 3 or quadrant 2. You follow me?
Yep.
So these pieces are chopped off. Chop. You don't need it. When you work with arc sine, what happens? You will be given the ratio and then you look for the angle. Do you follow me? That's how DRA, that's how it works on DRA. So it's still DRA. Hold on, sorry. Okay, it's still DRA. Okay, but with the third quadrant, the second quadrant and third quadrant all cut off. You follow me? You're not going to have any angle from here. Do you follow me? That's the correspondence between the unit circle, part of the unit circle, and the arc sine curve. Do you guys follow me? Yes? So when you give me a ratio, sine ratio, suppose you give me, √2, square root of 2 over 2, then you'll be looking for the blue number. Okay, you'll be looking for the blue number from the blue number to the angle. And the angle has to be between -π/2 to π/2. So that's the recap. Do you have any questions? Thank you, Corlin. It's clear. Okay, notation-wise, okay, a lot of our students make mistakes on notation. I certainly give you exercise on notation, and we have done a fair amount of notation in class. So any mistakes I see in that line, or any mistake you make in your future calculus classes, you better be aware, okay, how to write it. We have plenty of examples in class. But anyway, without further ado, now we're going to look at a cosine. Okay, with everything we've gone through, right? The truncation, the unit circle, and all of these ideas. A lot of these ideas are similar to cosine. But for cosine, there are new considerations. Any questions so far? Okay. Okay, so let's look at cosine. All right, so I have put together, okay, a similar setting. We're going to talk about, we talk about sine, we're going to talk about cosine, we're going to talk about tangent, arctangent. These three functions are very, very important three functions that you are going to use in trigonometry, in calculus classes. It does not mean you're not going to use cotangent or cosecant or secant. You use them to lesser extent. So I'm not going to cover the other three functions in class, but you need to do that yourself. Okay. And I will still be testing you or quizzing you on those functions regarding domain and range and stuff. Like I had given you those questions, right? Arc, cosecant, domain, and so on and so forth. You should be able to decide that, okay? Will cosecant, secant, cotangent be used in your calculus classes? Absolutely. Absolutely. Okay. We just won't have time to cover all 6 functions. A lot of them are similar. A lot of things are similar for those other 3 functions. Then you need to commit yourself to, to work it out. Okay. But anyway, so now cosine. We know that cosine is a periodic function, right? We know cosine is a periodic function. And we look at the unit circle. You can see so far, we've been using unit circles for how long? Very long time. Okay. This is we're still trying to digging out that 1,000 words in the picture, right? ARD, DRA, different perspective, and one-to-one. So all of these, they actually all originated from the definition. They all originated from the definition, nowhere else. So if you just focus yourself on the definition, okay, spend a little more time on it, everything else is come together in one place. You don't have to visit, 10 places, just one place, one visit, but thoroughly, completely. Okay. All right. So let's look at cosine. So once again, okay, I trust you guys have reviewed cosine, right? Have you done some review? What kind of function is a cosine? It takes angle, right? It produces ratio, right? It produces ratio. The only difference is the ratio is different, right? We still have the ARD set up. Positive angle, negative angle, same rule. Reference angle, the same rule. And thirdly, the only difference, that's right, Cortland. It's not 1-to-1. You got it. You know where I'm heading. It's not 1-to-1, right? So cosine A as cosine function as a function, it's not a 1-to-1, okay? Because it's not going to pass what? It's not going to pass the horizontal line test, right? It's not going to pass the horizontal line test. For the same reason, it's not a 1-to-1. If it's not a 1-to-1, it certainly doesn't have inverse, okay? So now, before we move forward, what is the domain for cosine and what is the range for cosine? Can you tell from the picture? Can you tell from the picture? From
domain is negative infinity to infinity or all real numbers, and then the range is negative 1 to 1.
That's wonderful. That's the wonderful answer. Okay. The domain is from negative infinity. What does it imply? It can be any angle. It can be any angle. Radian degree doesn't matter, really. It can be any angle, positive, negative, any real number. Because whatever you input for cosine, it will be regarded as an angle. You say, oh, I'm going to enter 1/2. It's going to be treated 1/2 as an angle, not as a ratio. So whatever number you give to cosine, it will be treated. Okay, it will be treated as what? As an angle. Okay, angle, there are 2 forms, either is degree or radian. If you don't have a degree sign with it, it's going to be treated as radian. Okay, and what is the range? What is the range?
Negative 1-to-1.
Very good. You can see it's in the picture, right? It's between -1 and +1. So, okay, so let's first write these down. Okay, -1 less than or equals to cosine equals to +1. That's one of the form of the range for cosine. And this is the form I'll be testing you over and over again. Okay, cosine A less than equals to 1. Okay. The other form, which you guys may be most familiar with, is correct, but totally useless, usually. Okay. And another piece of words or sentence I want to nail to you in your head is for any real numbers. Okay, so this is domain range together. We had a similar requirement. We had a similar statement about sine, right? Domain range, one sentence. Okay, like Cortland says, right? This is not a one-to-one function. Can anybody give me a reason? Anybody give me a reason? Why? Why it is not one-to-one? By this time, we're pretty familiar with this technique, right? Why it is not one-to-one? We're going to go back to the definition of one-to-one function and quote that statement and counter that statement, right? So can you guys try to give me some statements? Type it on the chat, please. Type it on chat. Okay. Please do. Why it is not one-to-one? You're absolutely right. It's not one-to-one, but why it is not? Quoting definition, okay. Cosine A is not one-to-one because whenever x1 does not equals x2, f of x1, that is a false statement, Cortland. Whenever x1 does not equals x2, f of x1 is equal to f of x2. That is not a true statement. Okay, Kevin's answer, cosine pi over 6 is equal to cosine 11 pi over 6. And what does this imply, Kevin? Cortland, do you see why it's not true? The statement you made was not true?
I don't see why.
You don't see why. Okay, when you say whenever, you're basically telling the reader for any two that are not the same, their function value will be the same. That is completely not true.
Oh, okay.
Do you hear the word whenever you use there is very, very powerful.
I see.
It says for any pair. Okay, Kevin, if you can just try a little bit hard, well, Kevin's answer actually is pretty good already. Okay, I still want to emphasize this method. I've been, I taught you how to read a definition, how to counter definition. This is a crucial technique. This is a crucial thing for you to do in calculus. You're going to be doing that on a daily basis, every single day. If you don't know how to do this, right, even though you're going to be doing this with the concept of limit, the concept of continuity, the concept of differentiability, and numerous other definitions and theorems, if you don't know how to do this, you literally will get very few points. you have to remove the word whenever, because whenever is there, you obviously is not doing whenever, right, Kyle? You're not doing whenever. You just say, okay, for some, you counter the counter. What is the counter of opposite? What's the opposite of whenever? Huh? So let's revisit this definition. The definition of a one-to-one function is whenever. What is the opposite of whenever? The opposite of whenever is also whenever. When? For some, right? Whenever basically is always, always, right? As in any case, x1 is not the same as x2, and f of the function. It's just for some. The opposite of whenever is that for some cases, that's not true. Do you follow me? What's the opposite of everywhere? Tell me, what's the opposite of everywhere? Tell me.
Nowhere.
Huh?
Nowhere.
The opposite of some of everywhere is nowhere. Not only nowhere. The opposite of everywhere is nowhere and somewhere. You follow me? What the okay? So we get to this point. You guys really need to understand this. You don't. You're not only going to lose points in calculus class. You're going to lose points in statistics class, probability classes. You're going to lose points on all these areas. Okay. What is the opposite of everywhere? Nowhere or somewhere. That's right. Nowhere or somewhere. Do you agree with me? You guys are, English is your first language, right? What is the opposite of everywhere? Do you agree with me? Somewhere. I think Mikhail's comment is more inclusive. Okay. Is that somewhere will probably include nowhere. Does somewhere include nowhere? that's the English with the sentence. But nowhere certainly is not is one of the cases of the opposite of everywhere, right? But there's another opposite of everywhere, is somewhere. Do you follow me? So now, what is the opposite of whenever? Okay, so I'm continue to type this. X1 is not X2. F of X1 is not equals to F of X2. Okay, I want every one of you to spend time with me right here, right now. I assure you, you will, when you're taking calculus class, you recall this day, today, and you'll be saying, okay, I think what we did then is worth it. So whenever, what's the opposite of whenever? So we're going to compose a definition of a not a one-to-one. Because any definition, right? Definition we're talking about here, what definition you have, you are going to study in calculus classes. Okay, you're going to study many definitions. At the time they tell you what is, at the same time it tells you what is not. Do you agree with Miss May? It's like this hand, right? At this time, once you know what's on this one side, it's also telling you there's another side. Yes? It tells you what is, at the same time it tells us what is not. And we have to figure out often what is not, what the opposite is not given as a definition. You have to figure out. We have to figure out. So what is the definition of not a one-to-one function? So whenever will be the opposite of will be opposite. You need to find what is the opposite of whenever. You cannot use whenever anymore. Do you guys see that, Cortland? Right? The moment you say whenever, you're making a false statement because what you said is simply not true. Agree, Cortland? Yeah, so you have to figure out what is the opposite of whenever. It is for some.
Oh.
For some, x1 is not the same of x2. F of x1 is the same of f of x2. Do you think that looks like the opposite? Okay, let's look at the new message, okay? Yeah, for 4, somewhere, very good. Okay, all of these are possible, are a good example, but you simply cannot use whenever. Do you follow me? Remember the examples we did in class? I said, I claim nobody in my class wears glasses. Right? I'm basically, everybody in my class does not wear glasses. How do you counter that?
You can use an example.
That's right. One person in your class, in my class, is wearing a pair of glasses. So that one example is what? For some, right? It doesn't have to be 2, you only need 1. But in this case, we need a pair, right? So that's why we say for some. You follow me? So let's go back to revisit Cortland's statement. You're not gonna, you can, it's okay with you, right, Cortland? Okay, let's revisit your statement. Okay, you made the statement says, I'm going back to see Cortland's statement. Okay, Cortland, please don't take it personally. I appreciate your contribution, but I just want to share this example to see how we modify this sentence to make it right. Okay, P said cosine A is not a one-to-one function. This statement is right. Okay, this piece he made, the statement he made here is right. Okay, that is correct. But what happens here is, what else is whenever x1 does not equal to x2, this piece is not true. This piece is not true. You follow me? Because I can instantly give him counterexamples. Could I give him counterexamples right away? Could I give him a counterexample right away? Absolutely. I'm going to give him the counterexample. Right? You said whenever x1 does not equal x2, then I'll give you x1 equals to root 2 over, I'm sorry, pi over 4. Sorry, pi over 4. X2 is going to be equals to pi over 6. And you're telling me whenever x1 does not equals x2, now I have a case, that's one of the cases in whenever, right? And I can tell you f of x1 is not the same of f of x2. You see, I counter you right there. Do you agree? That's why I'm saying you made a wrong statement. So because your statement is intended to support your conclusion, and this doesn't support. At best, you're gonna get partial credit. So you have to have the right reason. Okay, so let's go on. Look at Kevin's comments. Okay, Kevin's comments is a good one. Okay, because how would I read it? Okay, his comment. Okay, I'm asking you guys, please, there's nothing personal in this discussion. Okay, this is just meant to be interaction. Okay, in Kevin's comment, he says cosine pi over 6 is the same as a cosine 11 pi over 6. That's a true statement. The two input are different. Okay, therefore, this is a statement that's correct. Okay, so they are, I would say, it is not. It is not. And of course, and you would say cosine A is not a one-to-one function. Okay, so that's and Jocelyn said it does not pass the horizontal line test. That's a good one too. That's more visual, but you still have to be able to verbalize it. You know what I mean, Jocelyn? You still have to be able to verbalize that, and that will be a required skill in Cal. Okay. Now, and Kyle says whenever x1 is not equals x2, f of 0 equals 1 and f of 2 pi equals 1 should not be the same. Well, your example is not a whenever case, right? And you say, Kyle, are you there? You say whenever. When you, in this case, you counter that, you certainly cannot use whenever. Okay. And also, you cannot say when x1 is not the same of x2, because not all cases of x1 is not the same of x2, and they will have the same answer. Should not be the same. So your words here, like whenever, so I'm gonna copy this and I put it over here. I'm gonna just show you how to make the correction, right? So first of all, this whenever is not the right word to use. Okay. Well, x1 is not equals x2, f of 0 equals 1, f of 2 pi equals 1 should not be the same. The should be gone. Okay, the should be gone. I'm getting there. Okay, I'm getting there. Let's see, there's a new message out there. Are not the same. Are not the same. What do you mean? What are not the same?
So instead of using should not be the
Are you
same,
talking about the input are not the same, or you're talking about the output are the same?
so for the output, we should put are not the same instead of should.
Okay. So in this case, I'll be confused, right? You tell me f of 0 equals 1 for cosine, which is true. I agree with you. And you also tell me f of 2 pi also equals 1, which is true. And then you in turn, you tell me that you're also telling me, and there's a consequential word here, you know, then, right? Then, and then you say, you change should to are, right? And do you mean the output not the same or input not the same? You see here is not clear because obviously 1 is the same as 1, right? The output are the same. And you tell me they're not the same, and that's wrong. But if you tell me the input are not the same and you didn't specify, you need to specify
Okay.
that. Do you hear the confusion in here?
Yeah, I hear.
So how do we correct it? You can use the word for. Somebody, you know, Andy, you pointed out, you can use the word for. Okay, because you obviously have chosen the x1, which is 0, and the 2 pi. You have chosen the right example, Kyle. Okay, you can just say, okay, f of x1, I'm sorry, x1, x sub 1 equals 0, and x sub 2 equals to 2 pi. Right? And you say they're not the same. What are not the same? X1 is not the same as X2. These two are not the same. But like you pointed out, f of these two are the same. I hope this might be a translation for what you meant. I mean, a correction. Do you agree with me?
Yes, I agree. Yeah.
Does that make sense? So one thing is you understand it, and the other thing is you have to be able to verbalize it, and with a strong logical conviction. You have to convince the reader what you said. Whatever you said is true. Okay. You have to promise me all you say is true. Okay, because every word you say will be judged. We don't judge people, we judge your work. We judge your work. And criteria, definition. Okay. Kevin's comments here is a shorthanded version, which is sufficient. Okay, because the reader can read, right? This is pi over 6. Right, 11 pi over 6. Okay, so I hope this is helpful. Okay, this skill is a practiced skill. No one was born with it. I wasn't born with it. I don't think anyone was born with it. Were you born with it?
Breathtaking $550,000 on Tesla, where he initially purchased 862.
Okay. This is called critical thinking. This is the kind of skill we call critical thinking skill. Okay, you will see this used very often in math and in statistics. And if you, some of you, I believe every one of you will be taking some statistic classes in this day and time. Processing data is a big thing. Okay, then you have to take a probability class, and in those classes, the logic of strong logic training is basically required. Okay, so I hope you take it seriously, as why I take the time to work with you on these matters. Okay, all right, so let's move forward. Any questions? Okay, all right, so we just discussed that the cosine is not one-to-one. You see how to make that statement. Okay, how to make that statement. Okay, so we're going to move forward. Okay, if it's not one-to-one, therefore cosine does not have inverse. Okay, so cosine does not have inverse. Does not have inverse. Then what do we do? Now we're going to do the old trick, right? So we're going to do truncation. We're going to do truncation. So how do we truncate? When we do truncation, we basically want to leave a piece that is one-to-one, right? But this piece has to cover everything in the range, because when we create a one-to-one function, we want to create a one-to-one function. How do we create that one-to-one function? The easiest way to create it, okay, we know the cosine is periodic, right? Can we use this piece? We can truncate from here, and chop everything else. Leave this piece. Would this piece be one-to-one? You
Yes.
follow me? Yes, it is one-to-one. It passes vertical line test, horizontal line test. Where is this from where to where? This is from where to where? What is this point? What is this point? If that's the way you want to truncate it.
Is it pi over 2?
What?
Is it pi over 2?
Pi over 2? This is pi over 2? Suppose I want this piece. Is this pi over 2? This is pi over 2. Cosine pi over 2 is 0. This is pi over 2. This is pi. This is 2 pi. So can you mark these 2 points? Hey, you guys, I think we need to do a little better review on this one then. This point is pi -1. Okay, cosine pi is -1, right? And this point, what is this point? What is this point? It's 2 pi 1, right? So this piece will be a one-to-one. Yes, so we have many pieces to choose from. But this piece is not the piece chosen by the early mathematicians. The chosen piece is actually from here to there. The chosen piece is from here to there. Right here. Everything else is truncated. Truncated. And everything else being truncated on this side. So now, can you describe these 2 points for me? What is this point? You have unit circle to refer to, right? You have a unit circle to refer to. What is a cosine 0? This is a cosine 0, right? This angle is 0. So it's 0, comma what? 1, that's right. How about this other point? Hello, everybody. Okay, does everybody follow me? So this piece is chosen. What did this piece corresponds to? Which quadrant it corresponds to on the unit circle?
Quadrant 1 and 2.
That's right. Quadrant 1 and quadrant 2. So what happened to quadrant 3 and 4? You follow me? And the making of the curve is still the same thing. We just simply take the arc length and the red number. Arc length and the red number. Yes? Arc length of red number. For example, okay, let me review. Let me review, okay, if you understand this curve, right? All right, I'm picking a point. I'm picking a point. This point, okay, is right here, okay, at the same height of 0.5. I want you to mark this point. Can you mark this point and tell me what this point is? Is my question clear? Is my question clear?
Yeah.
So can you mark that point?
Is it pi over 6 and 1/2?
Can you put it on the chat? Pi over 6, 1/2. Cosine pi over 6 equals to half. So unit circle is right next to it. I'm not telling you don't need to use it. You can use it. Okay, one answer is pi over 6, 1/2. That's wrong. Try again. Where do you find the cosine ratio equals to half? You're looking for the red numbers, don't you? Definition. Cosine of an angle is x over r. It's the red number. That's right, pi over 3/2. Okay, what is pi over 3? Right? This is pi over 3. And what is a half? This is red is a half. Okay, this red is half. And what is the purple? The purple is a measurement from 0. It's the same arc length as what? These two purples are supposed to be the same length. Well, my drawing is the problem. But they're the same length. Do you follow me? Yes, everybody. Do you follow me? You understand? It's the same as sine. The arc length is straightened and I turn into this piece. Okay. I can make it a bit longer. Okay. The purple. Okay. The stars here. And the purple. Oops. Does everybody follow me? There's a purple piece here. That purple piece is straightened up. It turned into this purple piece. Okay, and the red is the red half. Is this half? You guys see this number? Right here. Does everybody see that?
Yeah.
Yeah?
Yeah.
Many of us remember this unit circle point for point, but you have to know how to use it. Right? All the red numbers are a cosine value. Cosine angle, because cosine by definition is what? It's x over r. All these red numbers are x coordinates. And it's a unit circle. Isn't that definition important? Your mind is constantly on definition. Our mind should be constantly on definition. Right here. Constantly on definition. As I'm teaching here, my focus in my mind is definition. Because I know everything is derived from definition. I don't need to take you to 10 other places. This trick and that trick. No, you don't need those tricks at all. The focus is definition. Trigonometry, the focus is ARD all day long. And you ace every exam if you get ARD. Okay, but if you don't, that means you didn't really understand ARD. Somewhere there's a hole. Okay, somewhere there's a loophole. Okay. All right. So the red number, you see, this is red half, and this is half. Right here, this half, what is that half? Right here. You follow me? So when we're making the cosine curve, all these red numbers, they're standing up. All these red numbers are standing up. Did you guys do this? I asked you guys to do it. Right? All of these numbers are standing up. Okay? So this half is over here, and this root 3 over 2 is going to be somewhere here. That's for pi over 6. Okay? You follow me? So all of these red bars standing up for cosine. Do you follow me? Everybody, please. We have 17 people here, including myself. We studied this same thing for sine. You are supposed to study the graph for cosine. Did you do that? Okay, so all of these red numbers, they turn into those red bars in these pictures, -1 and so on and so forth. And they're all from here. They're all from here. Do you follow me? All these red bars are standing here. Does everybody follow me? All right. So we mark that point. Okay. So we mark that point. Okay. So let's clean this up. Okay. We decided we're going to truncate. We're going to truncate from here to there. Okay. I'm going to mark these 2 points. So could you guys mark these 2 points with me? 0, 1. And over here, pi, -1. How was this done for sine? How was a similar thing done for sine? How was the truncation done for sine? Is it from 0 to pi? It's from -pi/2 to pi/2, right? Different pieces, but similar ideas, isn't it? Do you follow me? So for sine, what was done? The sine, we truncated from -pi/2 to pi/2. I want you guys to get that piece of notes and you lay them on side by side with what we're doing right now. Do you have the notes for sine with you? And put that on the side so we can do a comparison. So you can do a comparison. Do you see that? So how the truncation was done for sine? From -pi/2 to pi/2. Why can't we do the same for cosine? Why can't we do the same for cosine? Wouldn't that be nice? Wouldn't that be nice? And suppose I'm going to truncate from the same places, right? So let me show you that piece of curve. Right? This is -pi/2 to pi/2. This is the cosine curve. Can we do -pi/2 to pi/2 for cosine truncation? Okay, so do you guys understand my question? Do you follow me? Cosine curve from -pi/2 to +pi/2. Can we truncate this piece? And that truncation will be the same as sine truncation, right? From -pi/2 to pi/2. Can we do that? Mikhail? Michael? Mikhail? Michael? Is it Michael?
Michael.
Michael, I'm sorry. Michael? Can we truncate for cosine curve, negative pi over 2 to pi over 2, the same interval we truncate for sine to produce one-to-one function?
Yes.
Are you sure? Is this curve one-to-one? Yes?
They're not. Because if you do like the,
It doesn't pass the horizontal line.
yeah, if you put lines through the graph, we have 2 points. Like if you put a
You put
line,
what line on through the graph?
like from like an X,
Is this piece of curve one-to-one? Mikhail and everybody else, tell me. If I truncate the same way as sine, okay, sine truncated from negative pi over 2 to positive pi over 2. If I truncate from negative pi over 2 to pi over 2, okay, this point is negative pi over 2, comma 0, and the other point is, Aaron says horizontal line on x-axis 1, not 1-to-1. So this piece is pi over 2, comma 0. It is not 1-to-1. If we truncate this way, it's not a 1-to-1. So you still don't have inverse. Do you follow me? Okay. Aaron's comment is right because these 2 points, different x1, x2, but the same output 0. So that already tell us this is not a 1-to-1. And the other thing is you can arbitrarily draw any horizontal line. You're gonna have what? You're gonna have 2 of the equal. It's different input, the same output. Follow me? Same output. Different input, same output. So this is not a 1-to-1. No. Okay, I'm answering this question. It does not make a 1-to-1 function. Okay, so I'm waiting for you to write it down. Okay, I'm throw all these questions at you. And invite your participation and thinking. We pretty much rethink, okay? Those mathematicians who did this many, many years ago. We're going through the same journey. Not exactly the same journey, but it's similar. Trying to figure out how to create that 1-to-1 function. So if we truncate the same interval as we did for sine, it's not going to work, even though that makes it sound very simple. But this is the place where sine and cosine, arcsine, arccosine differ in these small details. Do you follow me? Okay. So now the question is answered. Did you guys take notes? Okay, so I'm going to put this away. Okay, and as a result, our truncation is going to be between these 2 points. Everything else chopped off. And this piece is 1-to-1, corresponds to quadrant 1, quadrant 2, and quadrant 3, quadrant 4 are not considered. Okay, so there's a new function that we're calling its name. Okay, and we know its name pretty much. It's arccosine. Is coming out. Is coming out. Do you follow me? This arccosine is coming out. So what's the consequence of this what's the consequence of this truncation? We truncate cosine from 0 to pi. Truncate cosine curve from 0 to pi. What's the consequence? That is, right? We did this on the curve, just drop, but algebraically, how do we express it? Is a cosine A, and A is between 0 to pi. That's a description of this piece of curve from heart to heart. Everything else is off. And this function, okay, this function, along with the interval description, is 1-to-1, and it has an inverse. It has an inverse. Okay, 1-to-1, it has the inverse. Now, how does the inverse look like? What's the domain of range of this inverse? Okay, so let's do a little bit summary. I don't know if you guys are closely following me. Okay, I'm gonna do a little summary, little recap before we move forward. Okay, like we did earlier, like what we did earlier. Okay, the cosine function, its domain, its range, right? We know that endless curve, that domain is from negative infinity to positive infinity. And the range, cosine A, is between -1 and +1. And of course, we have another form, the absolute value less than or equals to 1. Okay, so now we're going to put a restriction. This is new function. We're going to have a new function. Okay, new function. This new function still called cosine A, but it has a new domain. 0 to pi. And the range, same. Range is the same. This new function has inverse. This new function okay, the inverse to the new function, what is it? We call it arc cosine x, which is also written as a cosine inverse. Cosine inverse x. Okay, so what should be the domain for the new, the inverse function to the new? These two are inverse to each other, right? So one's domain should be the other's range, yes. One's domain should be the other's range, yes. We said all inverse functions have the same relationship, right? One's domain and the other's range. So for this one, x, okay, is between, of course, x is ratio, okay. Sorry, need to be here, less than equals to 1. And the range is what? Right here. Or, okay, arc cosine is greater than equals to 0, less than equals to pi. Do you follow me? All right, so this is the arc cosine. So let's look at the curve. Let's look at the curve. Okay, so I'm going to draw arc cosine curve on this picture. Okay, I'm sure you guys can do the same. Arc cosine x. I'm going to make it red. Okay, I'm going to have to make it, make the, this is the arc cosine curve. The red is arc cosine. Do you follow me? The red is arc cosine. Oops. Sorry. Label. Two. I think I can make it red. Do you guys follow me? The red is our cosine. Do you follow me? In all of your studies from this point, okay? Let me look at the comments. Cortland says the domain of inverse, I think you mean inverse cosine, all right? It's -1 to +1. That's correct. Does there need to be absolute value? Where? Here? No. It's between 0 to pi. So arc cosine always give you non-negative value. The value is between 0 to pi. Arc cosine will never be negative. You don't need absolute value. You don't need absolute value. Do you follow me? And in most of cases, okay, I'm going to cut this. In all of the cases you study, okay, in all of the cases you study, this piece, in all the work you do from this point on, we rarely use that transition new cosine function. The function you're using are these two. You follow me? The function you use are always these two. They're not inverse to each other. We understand that, right? That's what confuses people, just like a sine and arc cosine. The two functions we use often, they're not inverse to each other. Okay? These two are inverse to each other, right? The highlighted part I just put in there, they're inverse to each other. But we rarely use them. So this piece is rarely used. That's what makes it difficult, because people tend to think that these two are inverse to each other. No, they're not. These two are not inverse to each other. This last one and this second one in the middle, they are inverse to each other, but this one is rarely used. Okay, rarely used. Okay, so let me put it here. Rarely used. So you should never be confused. Whenever cosine is referred to, it's always referring to this cosine. Do you follow me? Does everybody follow me? So in the future, or in this class, okay, we will encounter those questions, okay? In the future, or in this class, unless otherwise specified, the cosine we are addressing is always this one. Okay, the cosine we are addressing is always this guy. The arc cosine we are addressing is this guy. These are rarely used. That's rarely used. Okay? Now, let's see how we use these curves. Okay, let's see how we use this curve. How do we get the numbers? How we write them correctly, properly? Are you ready? We're going to mark some points. Guess what? I'm going to, I think this is fine. Okay, you can see that 3.1. Okay, so you see from the red curve, okay, the domain and range is very obvious. Okay, so this piece, okay, this piece, do you guys see that? That's a domain and range for arc cosine. So this picture, what does it tell you? What does it tell you? Domain is from -1 to +1, right? Domain is horizontal. Range is from 0 to pi. So now let's mark a few points on these. This point, what is it? What is this point? What's this point?
-1 comma pi.
Pi, that's right. How about this point?
+1 0 comma 0.
Perfect. So whenever you work with arc cosine, what are those arc cosine values? Right? Give me a couple of arc cosine values. Arc cosine takes ratio, produces angle. Okay, arc cosine takes ratio, produces angle. And the ratios between -1 to +1 and the angle are always between 0 to pi. You follow me? Is that pretty clear? So when you punch that, when you say, oh, I want to look at the cosine curve, how the cosine curve look like on my calculator, you get that curve, and you should get this message instantly. These information is right there. Do you follow me? Now, how do we find them? You can use a curve. You can also use a unit circle. Okay. So now, as you're writing it down, I'm going to give you a little bit more information from other perspective. Okay, because I hope you guys will thoroughly understand this. Thoroughly understand. And then you'll never lose points because of it. Okay, so I'm going to make this just a little bit smaller. Okay, I'm going to just make this a little bit smaller so I can type some of the same things on the same page. Okay, so the cosine is always what we refer to here. Okay, domain range in one sentence. This one doesn't go. Okay, so there's a domain range in one sentence. So let's look at cosine. Okay, all of these information here. There. Arc cosine as a function. Arc cosine as a function. What kind of quantity taken as input? The input is ratio. Okay, so whatever number you give it, it will be treated as a ratio. And that ratio will be checked. Okay, this ratio will be checked. This ratio has to be between -1 and +1. Then you say, what if it's outside? Well, it will be considered undefined. Will be considered undefined. Okay, this kind of ratio is taken. And the output is going to be angle. Okay, what kind of angle? Arc cosine angle between 0 to pi. At this moment, I want you to compare with sine and arc sine. from these comparisons, you see a lot of things. You see a lot of things. Our time is running out, is running up. Okay. So you should be doing the comparison. And you may not have completed the homework I assigned you last week. And you can see that the homework are related to these stuff. Okay. So if you think you did your homework, you may like to go back to check your answer. Okay, even though I don't collect your homework, but I will test your effectiveness on your doing homework. So your quizzes covers questions from your homework. You notice that, don't you? Okay, so you should go back to your homework to work on those arc sine, arc cosine. If you haven't done arc cosine, or you're not sure you got the right answer, and this time you should go back there. Tomorrow we're going to be doing some more for arc cosine, okay? Any questions from you?
No, thank you very much.
Thank you guys, very good participation. I really appreciate it. I really enjoy the interactions with you. All the contributions are much appreciated, okay? So keep on contributing, and I hope this interaction will make it a valuable learning experience for all of you, for all of us, including myself, okay? For me, I cannot emphasize enough how much your contribution helps me to address those issues that I think is very important for our understanding, okay? So when you contribute, whether your answer is right, wrong, partially right, partially wrong, and so on and so forth, please don't take it personally. There's nothing personal about mathematics, okay? Just a matter of factly. That's just a matter of factly, okay? And it's all, we all work for the same purpose, which is make ourselves better at this subject, okay? So I will see you guys tomorrow, and I probably will assign you some I will probably assign you some new homework. But meanwhile, keep on, keep up with your good work, and I'll see you tomorrow, if not sooner. Okay. If you need to see me in my office, that'll be terrific. I'll be right there. Okay.
Okay, have a good one.
Have a great day.
You too. Thank you.